Hi everyone, Miss Barber here for lesson 1.9, the final one for chapter 1 in Algebra 2, Introduction to Parent Functions. So every function belongs to a family of other functions whose graphs have similar shapes. So each starts with a parent function. So the parent function, you can think of it as the most basic function that exists. So remember linear functions. We've used these lots before in our math. So the linear function is a straight line, and it's just f of x equals x. So equaling x, that's just my linear straight function. We go through the point 0, 0, and we have a slope of 1. We've seen it a lot. We've added different slopes to it, different y-intercepts, but those are all transformations of my original parent function. The second one is quadratic, and quadratic is x squared. So that's where you get this U shape, which we call a parabola, where the vertex, the bottom of the parabola, is at my origin 0, 0. Cubic is x to the third. So we're basically just changing the power of x. So now we have x to the third, and it's this shape here. And again, the middle of the shape where it turns from being concave down here to concave up is through my origin 0, 0. Finally, the last parent function we'll talk about is the square root function. Think about taking the square root of a number. You have to only take the square root of a positive number, which is why we are only with the positive x axis here. And as you take the square root of a number, you're going to get a shape that looks like that for the bigger value of x's. So those are the 4 parent functions. So every one of these following problems is going to look like one of these 4. It's just going to be changed somehow, transformed. So either move left, right, up, down, get skinnier or fatter. So example 1, identify what this parent, how is this function like the parent quadratic function? How is it different? So if you look, it's identical to the one above. The only thing that changed is now instead of starting at 0, 0, we're starting at negative 1, 0. So we moved 1 to the left. So we move 1 to the left. And that transformation is called a translation. So moving left, right, up, or down is a translation. So we translated left 1. Number 3, you should look, this looks a lot like my square root function that I started with. Except now, my original square root function went like this. And this is now flipped over the x-axis. Flipping over the x-axis, the math term for that is called a reflection. You probably remember that from Algebra 1 or geometry. So we just reflected it over the x-axis. Now for these next ones, you're going to identify which is the parent function, graph both on your calculator, and see how it changed. So for this first one, hopefully you recognize that it's an x square root function. We have a square root, but now we have of x plus 4. So this is a square root. And this is where a graphing calculator would come in handy. So I'm going to move over to my online or my graphing calculator here called the Taculator. I'm going to go into y equals. In my y equals, the first one I'm going to type in is the square root of x. And then in my y2, I'm going to type in the new one, the square root of x plus 4. And I have to make sure, notice my 4 is underneath the square root. I'm going to press graph for both. The blue one, which was in my y equals, was blue, the first one, is my original parent function. And my red one is my new function. Because of the way I'm doing this on my iPad, the like width and height are a little strange. But the only difference between the red and the blue is my square root of x plus 4 moved 4 to the left. And we know that is a translation of 4 to the left, so we can write that down. So we translated 4 to the left. So pause the video and try number 6. I'll give you a hint. You're also translating a certain amount. Which way are you translating from your parent function? So pause the video, try it, and then check your work. Number 7 we'll do together. So number 7, I have 4x squared. Well, x squared, so my parent function was y equals x squared, or f of x equals x squared. So let's go ahead and put this in. So in my calculator, instead of my square root function, I'm going to put in x squared. And then here I'm going to put in my new one of 4x squared. So this is my translated one. So the blue will be the original, and the red will be the new one. Hopefully you noticed the red one got a lot skinnier, okay? So the skinnier, you can think of it as a horizontal compression. So blue was wider, and from the sides we squeezed it in. That's horizontal compression. So we can go ahead and write that down. So this was a quadratic, and it was a horizontal compression. That's the official term. All right, moving on to the back, example 2. Identify the parent functions to model each data set. So we're gonna have to graph it and then determine how it was changed. So for each of these, you're gonna graph the points. So -2, -9 is left 2, down 9. It's not gonna look great on my screen, I apologize. Then -1, -2, so left 1, down 2. Then 0, -1, and then 1, 0, and then 2, 7. So this is what my graph looks like. Comparing it to my parent functions above, you'll see it most resembles the cubic function. So this is a cubic. Looking here, my cubic, remember I said it turns from going concave down to concave up at the point 0, 0. Now, instead of at the point 0, 0, it's at the point 0, -1. So this is a cubic function that got translated 1 down. So that's how you would do number 8. Pause the video, try number 9, and see how it compares to the original parent function. Remember, you can always check your answer on the school webpage under the key. Number 10, compare the domain and the range of the parent function of quadratic to that of a linear. So let's compare the domain and range. So remember, domains are x values. So I'm going to go up here to look at my linear versus my quadratic. So the green and orange here. Notice it doesn't matter your x values. Your x values, your domain for both can be anything. So for all x values, I have lines, and then for all x values for quadratic, I also have points on that graph. So the domain for both is all real numbers. So I can go ahead and write that. So for both, it's all real. It can be anything. Now let's compare the range. So now we're talking about y values. For linear, it looks like it can be any y value. It doesn't matter. I got y values everywhere. Remember, the graph extends beyond. Quadratic, notice I have no negative y values. I have no negative y's here. It starts at 0 and only goes above. If you think about it, it's because any number, when you square it, will become positive. So that's why my range is only 0 and above. So comparing them for my range, so the range for linear is all reals. Sorry, my phone is ringing in my classroom. But for quadratic, it's only the all real, so we'll still have that here, but your y has to be greater than or equal to 0 for the parent function. So number 11, this is a little bit trickier, but I know you can do it. So compare the domain and range of your parent square root function. So come up here to look at the parent square root function here and compare the domain and range between that and the cubic. So what can your x's be or not be? What can your y's be or not be? So again, try this on your own and then always compare your answer against the key. That's it for chapter 1. I hope you learned a lot and get excited for chapter 2, solving equations and inequalities.